Welcome alumni of TU Delft to the fourth evening of the TU Delft for Life Experience Week 2021 here at the Green Village on the TU Delft campus. My name is Lex Woodley and I will be your host this evening. The energy transition is the biggest societal challenge of this century. To achieve the climate targets, the Netherlands needs to generate much more solar and wind energy. But is our electricity grid even ready for this? To tackle this challenge, TU Delft has recently built a brand new lab, the Electrical Sustainable Power Lab, ESP Lab. 4 researchers will share their insights on this lab and the research that is being done, and we will do that inside. So let's go.
3, 2, 1.
Me tonight are professors Miro Zeman, Olindo, Isabella, Peter Palensky, and Pavol, Bauer. But we are curious to see who else is joining us tonight, and that concerns you, the viewers. We would like to get to know you better, so we have a few questions in the poll. And the first question is, what faculty did you graduate from? There are 8 options, and I'm curious which option of faculties gets the most votes in that sense. Let us see. Do you see on the screen which faculty has?
EMCS, yes, that's electrical engineering,
Indeed.
mathematics, and computer science. So it's the
Indeed.
faculty where we come from.
That is very good, isn't it? And yes, yeah, you agree. And we have another poll question for you, and that is, what year did you graduate? Let us know. Is it very recently? Is it like last year perhaps, or is it a few decades ago? That is possible. Peter, what do you see? Well, I think it is a few decades ago almost. Is
That's
it
good to see.
1990, 1999? Yeah, I see it. Good, great. Very welcome, everyone. So we are here in the Co-Creation Center on campus in Delft, but where in the world are you? Let us know on the map that you see. You can put a stamp on the place where you are at, click View Options, then Annotate at the top, and then select Stamp. And if you can't find it, no problem at all. Just leave your location in the chat. Now let's look at the map, the world map. And well, it is to be expected a lot from the Netherlands are viewing. And we also, I see the US there. Who do you see? I mean, which places do you see, Olindo?
Yes, apparently there is some alumni connected from the East Coast in the United States, someone from Italy as well.
Yeah,
I can see.
indeed. Indeed.
And someone from Belgium, I guess.
I see and I heard that someone is joining in from South Pole. So that is very, no, it's not on the map. So that's the information that I received. Well, very welcome, everyone. Nice to see people joining from all over the world, even the South Pole. Welcome to you all. And to make you feel extra welcome, we have a video with a message from our Rector Magnificus, Tim van der Hagen.
Samen. Dat is voor mij op dit moment het kernwoord. Dat precies samenvat wat we nodig hebben in het huidige tijdsgewricht. Of het nu gaat om klimaatverandering, gezondheidszorg, digitalisering of de energietransitie, radicale innovaties zijn nodig om ze het hoofd te bieden. En dat begint bij samenwerking. Er is geen bedrijf, overheid of kennisinstelling die dat alleen kan. Daarom zie je momenteel twee grote bewegingen in de kern van onze universiteit. Onze campus wordt steeds meer een plek waar industrie en academie hand in hand gaan. Er wordt hard gewerkt aan een innovatief ecosysteem met living labs. Door onderzoekers, bedrijven en overheid van meet af aan samen en dus op hetzelfde moment aan hetzelfde probleem te laten werken. Niet na elkaar, maar met elkaar. Daarnaast kruipen de Zuid-Hollandse topuniversiteiten in Rotterdam, Delft en Leiden letterlijk steeds dichter naar elkaar toe. Wetenschappers en studenten van het Erasmus Medisch Centrum en de TU Delft werken bijvoorbeeld samen aan de radicale innovaties die nodig zijn voor een toekomstbestendige gezondheidszorg. Samen dus. Dat is ook wat we in deze Xperience Week beogen. U mee te nemen en deelgenoot te maken van recente ontwikkelingen en ambities van onze topwetenschappelijke domeinen. Heel veel plezier!
TU Delft is working on one of the major societal issues of our time, the transition towards sustainable energy. To tackle the challenges of energy transition, the university is introducing the Electrical Sustainable Power ESP Lab. Miro, how did the idea of this lab come to life?
Yeah, the idea of the new lab came, I think, 12 years ago. And it was a part of much broader discussion, actually about the future of the department, which was at that time called Electrical Power Engineering Department and its laboratories. And at that time, there were people at the university who thought that electrical system was finished. It worked perfectly. And so there was nothing to add from scientific point to this system. Unfortunately, there were also people at the university who already saw all kinds of new trends in the society, and they recognized that these trends are actually big challenges for us. And I can name some of them, which today we actually frequently learn about, like CO2 concentration in atmosphere or air pollution. And those people knew that a part of this problem comes from energy sector. And it was obvious that we have to do something with the energy sector to change this. And so fortunately, they found out that we have to do it. And that term energy transition appeared, which we very frequently use now. And this energy transition already at that time was linked to this idea of a new lab. I didn't mention the name at present, but I would like to make one thing clear, and you stated it very well, that actually we are in the energy transition towards sustainable energy. Because energy transition is an infinite process. From the very beginning of human civilization, people were looking for suitable energy sources that they can then convert into useful energy. Maybe it was wood at the beginning, but last hundreds of years we are using coal, or we are using oil and gas, all primary energy sources based on fossil fuels. And what is special with the energy transition, as we refer to it now, is that for the first time on a large scale, we are going to replace these primary energy sources based on fossil fuels by renewable energy sources like solar and wind. And you can imagine that when you want to make this radical change, you first need to develop technologies that make it possible to convert this energy from renewable sources into useful energy, like electricity or heat. And then it's not all that you have to do. Then you need to couple this useful energy, like electricity from these renewable energy sources, to the existing system. And we are in the department developing also these components. We are calling them inverters or voltage conditioners. So this is something that we were doing in development of individual technologies, individual components to facilitate energy transition. But what is actually the most important is whether when you put all these components and technologies together, whether they work together. Mm-hmm. So also a very popular term is system integration. And actually, our new ESP Lab, Electrical Sustainable Power Lab, is mainly focused on the system integration of these new technologies and new components that have to accelerate the energy transition towards sustainable energy.
And could you still emphasize what makes it so unique? Because we see lots of initiatives from people and organizations in the field of sustainable and energy, sustainability actually, and energy transitions these days. But what makes this so very unique?
So I can come together to the system integration. And what you do not want to do is that when you develop a certain component and you are not sure whether it fits in the system or not, you are not going to test it in the real environment. So you would like first to test it in an experimental environment. And this is what we are going to do in the lab. Now, again, I am mentioning some popular terms that we are using. One of them is also a digital twin. So what we are doing in this lab, we create a digital twin of Dutch electrical system. And then using this digital twin, we test in this laboratory whether the new components that we also develop in the laboratory, like solar cells, like inverters, like special cables for high voltage transmission, whether they can fit in the existing system. And this is what makes the laboratory so unique. Unique in the Netherlands, but we believe also unique in Europe.
To all the people that want to contribute to energy transition in society, what would you like to say to these energy heroes?
Yeah, I think, you know, energy transition is a huge challenge. And we cannot do it with 4 people or a department or university. We have to do it with everybody, every stakeholder in energy sector, companies, social organizations, everybody. And we are happy to do it together. So I would like to call these people who are really enthusiastic to carry out energy transition with us, such as ambassadors of energy transition. And when you want to do it with us, I would say, dare to change energy, dare to change energy with us, make this step towards sustainable energy.
Dare to change energy.
Dare to change energy. We are so far that we can do it.
So with me here at the table are also Peter Palensky, Olindo, Isabella, and Pavol Bauer. Let's imagine we are 30 years from now in the year 2050 or 2051. What would we see in society based on your research?
Well, the power system in 30 years is a very flexible, self-organizing, maybe even fractally emerging organism that is prepared for the unknown, because that's the only thing we know. Okay. The future is unknown. We will have new technologies, new applications, markets, participatory energy devices that talk to each other and so forth. The creativity of people is unlimited, but the power system has to host all of that, give them a home and make it work and swallow all the problems and fix them. That's what we will have in 30 years by the self-organizing, agile, intelligent power systems.
Thank you, Peter. And Pavol, how do you see it?
So I see electrification of society. It will be more electrical society for sure. We see electrification of transport, for example, electrical aircrafts, electrical ships, electrical cars are already here, electrical trucks. At the same time, some processes in industry will be also electrified. Electrification of industry will also continue. And houses will be also more electrical. We will get rid of fossil fuels, heating will be more electrical with heat pumps, etc. So electrical engineering, electrical energy will really prevail because it's a clean energy, flexible, easy to transport, to transfer, and very easy to also convert. And power electronics as a backbone of this electrical system, as the energy technology, will play an important role on the source side and also on the load side. We will get much more efficient equipment loads as we have today because of the power electronics.
Olindo, what could you add to what Peter and Pavol have said?
Well, in 30 years from now, photovoltaic systems, that is one of the renewable energy sources that we are talking about tonight, will be omnipresent and ingrained in both open and urban environment. We will see photovoltaic systems that are mass customized to serve all possible different requirements in terms of design, aesthetics, but also in terms of a higher efficiency. And especially in urban environment where we expect the vast majority of mankind to keep on clustering in next decades, the presence of high-rise buildings that can cast a dynamic shade on PV modules requires that our future PV modules will be resilient against shading. And in this respect, we believe that in the future, intelligent modules that we call reconfigurable photovoltaic modules will start having a good interaction with each other in terms of communication, in terms of electrical storage on board, and especially in terms of higher efficiency and also higher expected lifetime.
Peter, is our power grid ready for the energy transition?
The design and the evolution of the power system as a whole, and the power grid in particular, has a history and has assumptions that are 100 or 150 years old. These assumptions are centralized generation on one side, big power plants with lots of smoke and rotating machines inside, and the consumption on the other side, housing and industry, is following some patterns. They're consuming. That was the good old world, the dirty good old world. All that is removed now. And it's not removed in the next 150 years, no, it's removed in the next 15 years. So the pace of change is dramatic, has never been like that before. And it's comparable to when you drive a Formula One race and you change the wheels to magnetic levitation while driving. And we cannot switch off the power system and work on it for 20 years and then switch it on again. That won't work. So the power system has to change. All these new smart photovoltaics and smart charging and intelligent houses and heat pumps that talk to the markets and all these things that we foresee and that will come because they make sense, they have to be catered by the system. And that's why the grid itself also has to be smart. It has to interact with everything. It has to be self-organizing. Because currently, if you have a disturbance somewhere on the Balkan, like a few weeks ago, it can shut down everything in Europe if you don't react properly, which happens. So the grid companies do their job very well now, but these disturbances get more. The grid gets less inertia. So the assumptions that make everything work and stable are gone. We remove the foundation, so we have to change a lot. So as it is now, no, but the good news is we will make it work.
Olindo, what will the next developments be in PV, so in photovoltaic modules technology?
Currently, the photovoltaic market is dominated by crystalline silicon technology that in last couple of years has made this on a foothold on the market with extremely low and competitive prices. But this is only one part of the story. We need more and more efficient PV modules, and the way to go is to stack additional materials, photovoltaic materials, on top of the crystalline silicon, thereby making a cost-effective, so-called the tandem devices, double junction, or even maybe in the future, multiple junctions that can essentially, while having the same footprint of typical PV modules, have a much higher conversion efficiency. In this way, we can enable not only higher energy yield for users in the urban environment or maybe at the utility scale, but also enable a couple of examples of, like Pavol mentioned before, about energizing high energy loads that are needed for example, electrification of mobility and industrialization, electrification of industrial processes. So we need more efficiency.
And you mentioned urban environment. How to accelerate PV installations in the urban environments?
Yeah, the urban environment, as Miro mentioned before, there are several stakeholders that should talk and act all together. And I'm talking about the municipalities, I'm talking about different actors in the housing corporations and also distribution operation or transmission operation systems organizations. And it is important that when we start having more and more photovoltaic systems installed on the vast majority of buildings in the urban environment, all these installations are gonna disrupt the typical voltage signals that you have on the grid. And it is important that not only at the end user side, more and more photovoltaic systems are installed, but also at the grid side, more and more actions are taken in order to have the grid more resilient against all these additional installations.
In the future, we will see a lot of electrical vehicles, such as electrical cars, electrical ships, maybe even electrical airplanes. They are a big part of energy transition since they are basically batteries on wheels. Pavol, what developments do you see in this field?
Okay, let me repeat that big battery on wheels, that solar energy, wind energy, due to intermittent character, and storage is the winning combination. It's really winning horse. We need a storage and flexible storage, and vehicles are such a flexible storage. So they are really creating a good combination. What we are doing is research on electric charging technology, and there are several developments. Ultra-fast charging, we are developing ultra-fast chargers with very high efficiency, reaching 99% efficiency from the charger point of view. At this moment, it's for highway charging, ultra-fast charging, one-to-one, one car, one charger. In the future, I foresee, we envision some kind of system with more cars with one charger connected, especially in the cities, in urban environment, by supermarkets or by hotels, where the cars can be charged on different speeds depending on demand. This is one of the developments we are following. Second one is the smart charging, which is charging from energy from the solar, wind, charging to avoid congestions, charging with the price signals on the low level, charging to avoid peak power, and maybe power the grid, vehicle to grid development. All these demands are sometimes contradictory. So smart charging is a big optimization algorithm where, for example, artificial intelligence can play a very important role. And the third one, which we foresee, is the contactless charging. In the future, we will have vehicles driving autonomous vehicles. And of course, it doesn't make sense to have autonomous driving, but somebody has to plug it in to the charger. So contactless charging with very high efficiency. And I would say we have a world record maybe in our ESP Lab of 96% efficiency for 3.7 kilowatt charger on 12 centimeter distance, technical details, but it can be done very efficiently. So these chargers will be everywhere, connecting the cars where needed, charging or discharging the car, supporting the grid, supporting the house. It will be maybe energy on demand. The car will come to your house and give you energy which you need to cook the dinner. And this kind of concepts can be changing the whole world of energy, how to perceive energy, how to market energy, how to buy energy, etc.
That sounds amazing.
So these are ideas. So when you listen to it, I think everybody who is listening should embrace it. Yeah?
Indeed, indeed.
So I believe in the coming 2 weeks or 1 month, almost everybody in the Netherlands will watch a European Championship. So I hope that the same enthusiasm is now in people to really embrace energy transition.
Indeed, yeah.
Can I add to this? Sure. Football, because these are the moments when the grids are overloaded. In the break, when Dutch national team is playing football, everybody is going to bake bitterballs on the break or making coffee and tea. These are the peak moments for the grid. There we need a good storage to support it, and or we need a lot of energy from the solar energy. So let's hope that sun will shine on our players and they're going to win.
Right.
The ESP Lab is an amazing example of an integrated approach in tackling one of the biggest challenges of our times. And you might be curious to see more about it. Together with researchers from the lab, we made a virtual reality online tour to get a sneak preview on this facility. We will send you all the links by email after this event. But for now, a short preview.
Welcome to the ESP Lab. Academic, industrial and societal partners will come together in this brand new laboratory to get the Dutch electricity grid ready for the future. They are working on smart, innovative solutions to speed up the energy transition. At the moment, we generate electricity centrally in a few large coal and gas-powered plants. At a certain point, electricity will be generated locally using wind turbines and solar panels spread across the country. At the moment, electricity flows one way. Later, everyone will be both an end user and a supplier. At the moment, we simply supply energy according to demand. Later, we will be subject to the vagaries of the weather, so we need to find smart ways to meet the demand from the supply that is available at that point in time. In short, now is the time to work towards a future in which houses, neighborhoods, and even entire cities and regions are largely, if not entirely, self-sufficient in energy and are players in the bigger picture. And the ESP Lab? This is the place where researchers, companies, policymakers, business developers, and social scientists converge to make this possible. Dare to change energy.
Peter, what makes the ESP Lab unique to you, and how does it help you do research that couldn't be done without the lab?
The big advantage of the ESP Lab is that we deliberately brought everything together we need. We have high voltage materials, we have power electronics, we have supercomputers, we have digital communication, photovoltaic, everything is under one roof. And that's exactly the mix that we need to do integrated studies. The power system is rather complex. It will not get easier in the future. And we need a laboratory that reflects that development. And what we can do now, we can simulate an entire country with its assets in a supercomputer, and we mimic it in a digital twin. We connect machinery to it, real machinery. We cause a fault or a cyber attack to the system, and you see the machine shaking. So this is real. So every industry partner, every company that we work with really appreciates that what we do really flies.
And for you, the same question: what makes the Olindo? What makes ESP Lab unique to you, and how does it help you do research that couldn't be done without the lab?
Yeah, the ESP Lab is critical for achieving our scientific ambitions. And in respect of system integration, we study photovoltaics, we study wind energy, and how these inputs impact on the grid. And for example, connecting to the digital twin that Peter mentioned, one of the typical outputs of the photovoltaic part is to simulate the output power series of massively distributed PV systems, and how this power series can impact the grid in a virtual way. This is something that is already a unique features of interaction between the photovoltaic materials device group and the intelligent electrical power grids group. We have also interactions with the group of DC system energy conversion and storage led by Pavol, where we come to the point in which our smart PV modules, PV-based intelligent energy agents, will be embedded more and more with power electronics and with some form of controlling algorithms. This is where the interaction will come more in place. So the ESP Lab for us is a perfect place where to foster collaboration and really have our PhDs, our researchers interacting together on a daily basis to really make this change happen.
Pavol?
I think, well, I don't want to repeat what Peter said and Olindo said. I can underwrite this. It's completely true. I think it gives you also new impulses from this interactive multidisciplinary approach. You get completely new impulses even from different disciplines.
Can you name one of those impulses?
Well, I can name, for example, high voltage, which is a classical way of testing materials and devices, and power electronics, which is offering, for example, now testing devices built on for the high voltage. So these two disciplines are really merging together and creating new quality and new opportunity. And it's necessary also because the future grid will be power electronic based. So there will be not only good things, there will be also bad things brought by power electronics, by converters, such as harmonics and different load. And we need to test it. And the new laboratory is able to test it, not only for the high voltage equipment, but also for other components, for the grid, for the photovoltaics, etc. But this merger is giving us new impulses and new quality and new opportunities to create also scientific contributions. And this is really nice.
I would like to add this. I'm happy that my colleagues have mentioned that the ESP Lab encourages cooperation. And this is true. We have already mentioned that energy transition is a huge challenge for all of us. It actually affects all sectors, all levels of the society. And as a part of the ESP Lab, we aim to create a platform which we call energy transition solutions, not only for our colleagues at the university from different faculties, but really also for all stakeholders outside the university. So big companies like TenneT. TenneT is already a strategic partner of the ESP Lab. Then our distribution system operators like Stadin, Alianda, and Nexis. But also big companies from other energy sectors like gas, like Hasuli. But emerging companies like Shell, who really are stepping in energy transition and starting using renewable energy transitions, renewable energy sources. So I think that ESP Lab really helps to create this platform where all the stakeholders can come together and look at the solutions that need to be solved for accelerating the energy transition.
Could you emphasize why you want to be involved in the ESP Lab and do research in it?
Well, that's a mission. Huh? That's a call that you either have in yourself or not. I like engineering. I'm a nerd. I'm fascinated by the details, by technology. But we are now the generation that has to fix this planet. We have ruined it in the last centuries, and it's now our duty, but also our privilege to get it fixed. And with the ESP Lab, we have the tool for it now. We have concepts, we have ideas. Some of them will maybe not work, but we can try out everything in the ESP Lab. That's the point. Before we roll it out, we test it and test it and test it and understand it, and we learn with experiments in our ESP Lab. And it's motivating. It's a noble mission that we have, and it's great that we team up as an entire faculty with everything we have, including digital technologies and communication sensors, and make it happen in the ESP Lab. And the moment it works there, we roll it out with industry, and it can be used for the good.
Pavol, is the ESP Lab also connected to a calling of yours?
It's amazing to see so much advanced technology together in one lab. If you walk from one room to another room, your eyes are open, you will see different things, and always surprised by many views you can see, many technology solutions. And I think this opportunity of this ESP Lab gives us opportunity to connect them together. And this is what is called system integration. And system integration is very often mentioned as a buzzword, but we are really doing it. We are not talking about it on the paper, we are really doing it, and we have an opportunity to test it in the real life, in the real laboratory environment. And this is the uniqueness of the ESP Lab.
Olindo, I don't want you to stay behind in saying what it means to you.
Let me first make a definition. You can imagine that there are many different embodiments of PV systems, and In our group, we have coined this term XIPV systems. That means X integrated photovoltaic systems, where X is any type of possible surface where you can eventually embed a PV system, can be a build-added, build integrated, and so on. And our vision is to deploy XIPV systems for the control and support of the electrification of society. And this vision can only be done in facilities such as the ESP Lab, where our cells that come out from the clean room can be put into a layout to make PV modules that are smart, that can contribute to the electrification of society in a way that does not harm the typical utilization of the grid from everyone.
You have to understand, this is all fantastic high tech. This is brilliant technology that has the potential to save the world, but it will never work without our secret ingredient, with our secret weapon, the students. We are blessed with an army of smart minds that we have in our lab that work with us, and with that we can make it happen. Without them, it's impossible.
That's very nicely said. I would think that you agree as well.
Absolutely, yes.
Right? Yeah.
Our past students, so that's why we are turning to them, and we are inviting them to invent the future with us.
And send your kids.
Okay.
Grandkids, yeah.
Okay, now is a chance to ask your questions to our researchers. Feel free to post any questions you may have in the chat, and we will try to have them all answered. Now, normally we give the floor to a very special person, the alumnus of the year. But this year, due to the pandemic, we want to announce the alumnus of the year 2021 by a video. Here we go.
De alumnus van het jaar is een prestigieuze titel die jaarlijks wordt uitgereikt door de TU Delft en door het Universiteitsfonds. Dit doen wij omdat wij enorm trots zijn op onze alumni, een community van Delftse ingenieurs. Zij maken het verschil in de maatschappij en zij hebben de impact in de wereld.
De alumnus van het jaar 2021 komt uit een familie met veel technisch talent. In september 1983 begon ze haar studie hier aan de TU Delft, civiele techniek. En die ronde ze met succes af. Na haar studie in april 1989 begint ze als expert watermanagement bij Witteveen en Bos. En daar maakt ze een indrukwekkende carrière door.
Haar bijdrage aan het werkveld van de civiele techniek is enorm. Vanuit haar visie op de leefomgeving en infrastructuur heeft ze grote invloed op de ontwikkeling van ons land en draagt ze middels belangrijke functies, zoals lid van de Raad voor de Leefomgeving en Infrastructuur en lid van de NWO-board voor het domein Technische en Toegepaste Wetenschappen, hieraan bij.
Haar manier van leiding geven, altijd met oog voor de menselijke maat, is een voorbeeld voor velen. In 2018 werd zij in Londen uitgeroepen tot Europees CEO of the Year. Een bevestiging wat wij natuurlijk als TU Delft al lang wisten. Wij zijn enorm trots dat zij alumni is van de TU Delft.
Als kroon op haar indrukwekkende carrière en haar bijdrage aan BV Nederland in het algemeen. Ze is enorm inspirerend voor ons allemaal, zowel binnen als buiten onze community. Dames en heren, de alumnus van het jaar 2021 is Karin Sluis. Hartelijk gefeliciteerd, Karin.
Dankjewel, Tim. Wat ongelooflijk leuk. En wat een mooie, wat is het? Medaille, oorkonde. Heel leuk. Ik ben echt apetrots. Ja, jeetje, alumnus van het jaar worden, dat is natuurlijk wel... het is mentaal bijna het hoogst haalbare voor een Delftse ingenieur, toch? Ja. Dat je uitverkozen wordt om een jaar te vertegenwoordigen van Delftse ingenieurs. Ja, dat is ontzettend bijzonder.
Yes, it's time for the questions. And the first one is from Jan Metzelaar. Are we going to see Jan? Yes, there you are. Hello, good evening.
Good evening. I'm obviously very fascinated by all the technologies that are being developed, but what is the biggest challenge when it comes to energy transition? Is it getting all these technologies fixed, or is it actually the execution in the field? I believe it's the last.
I am looking at you. Yes, I'm looking at you, Peter.
I tend to agree. I think there are lots of fantastic solutions out there, technologies, but getting it into the field has societal, political, and other obstacles that could be avoided. And as an engineer, you sometimes believe, what's going on? Why is it not faster? But it's not. The world is not that easy. I recognize that. But a bit more persistence and a bit more speed would not hurt. We have to catch up with decades of pollution and other things that fall on our heads now, and every day later is a day too late.
Pavol, biggest challenge?
I think I would agree on that implementing this technology is very challenging. We have to dare. That's why also motto is dare too. And I think that really new things are happening only when you are prepared to make a risk to implement the new things. If you are going to be very conservative, you will never really do that. And we can see that on the countries who are really advanced in some energy transition issues, electric vehicles, for example, or more the solar energy, because they dare, and we have to dare. And dare to implement it. This is the biggest obstacle. Of course, I don't say that technology is developed completely. No, we have to do a lot of work there. There are a lot of challenges to overcome. But to dare, this is the motto of our laboratory. And that's why I think that this is the most important challenge.
Olindo?
Yeah, I would like to add that there is also, from implementation perspective, the need of more places where actually we are standing right now. A place like the Green Village, where there is a little bit of deregulation with respect to what you can actually do on the field, is something that would help immensely, because some of these technologies might have a little bit more experience in going maybe a little bit down with costs, and only when you start putting them on the field and testing them and getting some feedback to the engineers to get them perhaps more optimized or more efficient, then it will help a lot.
Thank you. And there is a question from Arjen van der Horst. Welcome. Arjen, what is your question? I don't really hear you. Could you, is it possible to turn your...
Yes.
Ah, what a difference.
Quite a lot. Okay, here we are. So we hear a lot about this energy storage and the various technologies that can be used to store this energy. But in order to be able to select the proper storage method, we have to have a bit of facts, data, graphs on how much of energy do we have to store and for how long. So do you know? Do we have any data?
I can answer as well.
Yeah. You go first and then...
Okay, so we have data. We know how long to store energy. Solution is in the hybrid storage, in the long-term storage, in the short-term storage. I would like to maybe stress there is a big discussion how storage will change the future systems and grids. For example, reliability issues are completely different with the storage because you have time to go there 1-2 hours and repair things. So many things are going to change, and storage is really playing a key role in energy transition. As I mentioned, the winning horse is combination of solar, wind energy, and storage, long-term, short-term, and alike.
Peter?
Yeah, there are different options of storage, and all of them have their peculiarities. If you store energy, energy is not a child's play. Energy has power, can destroy. So whatever medium you choose, you have to be probably careful. So you can store in batteries, you can pump up water a hill, you can compress air, and all that can store energy. But of a certain size, it gets serious. And some types of storage are very, very environmentally friendly, others are not. And that's the portfolio that we have. And all of them have pros and cons. And as Pavol said, we will have hybrid situations, and we will have a portfolio of different storages, different sizes in the substations, in the house, in the device, distributed, and all of them will be specialized. So don't hope for a silver bullet that will solve it all. Yeah, it will be a bouquet of different solutions that complement each other.
Then I would like to come back to the ESP Lab with your question. And we mentioned that actually probably the core to successfully execute the energy transition is the system integration of these new technologies, and storage certainly belongs to them. And within the ESP Lab, we can do it. We already mentioned the digital twin, and with the digital twin, we can not only generate the graphs of data, we can really simulate the new scenarios, including the storage. And this will probably help outside world, and now I talk about distribution system operators or even transmission system operators. What are the next steps in the future they have to take to really accelerate energy transition? And again, I can only stress the fact that storage is very important, and we need to take it into account.
The more concrete answer to your question is that we have a battery testing room. We understand storage. We can test different batteries for many months and understand their behavior. We have different setups, also testing the batteries or different storage options with the grid and with the power electronics. We have the data on the grids, on the behavior for the last 10 years, on the very, very big detail, 15 minutes, even 1 minute. So we can calculate the necessity for storage. There is a lot of projects related to that. And we can send you, if you write me a mail, I can send you some papers related to this topic.
Arjan.
Thank you very much.
And thank you, Arjan. And next question is from Hemkara. A very good evening. Are you
Yes,
muted?
good evening.
Yeah, okay. What's your question?
We were talking last year very much about windmills and solar energy and less about nuclear energy. What is the role of nuclear energy and maybe nuclear fusion? I don't know what the development is in that area, play in the energy transition. And does the Reactor Institute of Delft play a role in research in this field?
Peter?
In research, absolutely. We have to understand that subject, that discipline, that's a no-brainer. But in getting the energy transition done, in decarbonizing our society, we have to be much quicker. Even if you would have a nuclear power station concept that is accepted and safe and idiot-proof, which doesn't exist, but it will still take 40, 50 years to get it built. Let's be honest. These projects out there are a complete nightmare, and we have to be much quicker. And if you take a photovoltaic panel, you can put this into the hands of a monkey and they can install it on a palm tree. It's very, very simple. It's cheap, it scales fantastically, it's almost indestructible. This technology is so unbeatable on the market, and that's in the end what counts. So you have to compete on a market. Yeah? And nuclear energy is, unfortunately, it was for a long, long time the cheapest energy compared to all the other fuels. But now with wind and solar, it has no chance on the market.
So this is really a point that not often is mentioned, but economically, the nuclear energy cannot compete with solar and wind energy. When there is no really special breakthrough to make it more economically competitive.
So my question is, how about cyber threats? Can this be hacked, or what we are talking about?
It's me again.
Everything can be hacked.
Yeah.
Absolutely,
but here we have an expert out to tackle it.
One of the enabling magic tricks in the energy transition is digital technology. Without it, it wouldn't be that easy. We need more data, distributed decisions and controls, self-organizing, and so forth. So without the digital transformation, the energy transformation wouldn't be as quick as we wanted. So that's a fact. Good. So the digital transformation helps, but on the other side, it imports phenomena that we were not used to up to now, including cyber threats and cybersecurity problems. So yes, if every car and every substation and every photovoltaic panel and every cable starts talking to each other and markets and the internet and so forth, you could expect this is an attack surface, as we call it. And that's correct. And we have to make it secure. That's the only answer.
And that is quite possible, because I was hoping that you would comfort me, and it's like you make me a bit more worried.
Don't worry. No, it's absolutely possible. There are a number of very, very smart tricks in the area of cyber physical security, because let's not forget, the majority of the energy system is still physical. It interacts dynamically with the cyber part, so it's one cyber physical beast, but the physics helps. Yeah. So for instance, when you intrude the system and you manipulate sensor data in order to destabilize the system and let it collapse, a so-called blackout, you can do this in a cyber system very easily. Yeah? You hack a database or a bank and you can do these things, and then it's gone. Yeah? You delete things. In a cyber physical system, the physics is still there. You cannot fool it. Yeah? The plausibility and the sanity of the system is a loop between the physics and the cyber, and that helps. So we are much stronger than a normal cyber system.
Okay, I'm confident. Thank you. It's going to be fine. Next question is from Ronald Wild. Hello. Your question is?
My question is, you can create your energy as efficient as you want. You can distribute it as good as you want, but as long as people will remain addicted, there will never be enough energy. So
can you repeat that? As long as people remain what?
Addicted to energy, there will never be enough energy. You can be as efficient as you want. You can place solar cells everywhere, windmills everywhere.
So actually, what about the mentality transition? I think that is then what you are talking about, right?
I think you are fighting symptoms. You are not touching the cause of the energy shortage.
Pavol?
Yes, I think that this is change mentality takes a lot of time, that's for sure. But there are some incentives how to change mentality.
And they are?
Well, of course, we can talk about the sustainability, and we can talk about incentives that people will switch on the washing machine in the time when the sun is shining. All the incentives are also possible to translate in the money, that the people will be encouraged or even motivated to do so. And there are many, many incentives how to reach our goal. So the balance between the sources and between the loads, between the generation and between the loads, has to be achieved, unless we have to oversize the storage. And this balance can be achieved in many ways by the load shedding on the consumer side. So if there is not enough energy, you will be not allowed to switch on your washing machine. Sorry, you have to wait with your washing of your laundry 2-3 more hours. And this is maybe brute force, or price incentive will be enough. These are the questions which are going to be answered by acceptance of the consumers. And of course, that's why we need the cooperation between the people from the psychology and the consumer acceptance and the technology people. And they should come together and try to discuss these issues on open table.
I would like to add that this very important topic has also repercussions on the way how we interact with each other, and also the way we interact with our kids.
Do you have an example? I
have an example of my kids. For them, looking at a PV system or a wind turbine in the middle of the countryside is not necessarily an eyesore. So I think it has to do also with the way how people looks at these innovations and how they get used to that. We see, of course, a lot of challenges in embedding our new solutions, especially in case of PV modules into the architectural environment. but it is something that we are going to address. It is possible to have customized PV modules with colors, with textures, with a high efficiency. And it is just a matter of people looking at them more and more often. In other words, we have to keep on pushing for these installations. And sooner or later, people will come to not only accept them, but to like them, because it will be part of our life.
Do you see it the same way?
I would like to add one important thing, that there will not be enough energy. There will be always enough energy. Actually, the source is now shining on us. It's unbearable. And I can tell you that in 2 hours, the Earth gets as much energy that the whole mankind uses in 1 year, in 2 hours. So when we can tap just a little part of it, there will be not enough. There will be overflow of the energy. And as we already mentioned, the PV technology is getting so cheap that actually, like we are now calling with telephone, you are not paying for, let's say, how long you talk, you are more or less paying for your device. So this will be the same with energy in the future. Just to give you an example, in some countries, the kilowatt hour that the PV system generates is about 1.7 cents per kilowatt hour, 1.7, and it will be only and only cheaper. So I am not afraid that there will not be enough energy, and I am not afraid that this energy will be affordable, I don't want to say cheap, for everyone in the world. And this is also our ambition in the department at the university, and the ESP Lab is certainly going to help with us.
Thank you for your question, Ronald Wild. And the next person who we're going to see and hear is Guus van der Schouw.
Yes, hello, I hope you can hear me.
Yes, we can.
Okay, yeah, I had actually another question that follows up a bit on our discussion that we had on storage. Because we're talking mostly here about the short-term balancing. You talked about indeed putting off your washing machine for a couple of hours. But what about long-term imbalancing? But for instance, in the Netherlands, if we really decide to change all our heating for electrical heating, we'll have much higher demand in winter. And I mean, at least up till now, I think it's not really feasible to build like seasonal storage. That would be really prohibitively expensive. So how do you see that, in particular in the short term? Because in the long term, of course, we say we'll get it from Spain or from Morocco. But it's an issue that will already start in the next couple of years if we really start switching.
Well, long-term storage, maybe Miro can talk about the program we have in the TU Delft, which is called eRefinery. And the goal of this program with 12 PhDs and 4 assistant professors is just to make long-term storage in the molecules more affordable and cheaper and more flexible. And we are working on the solutions. It's not only hydrogen. Hydrogen is one of the potential storage options, but we are talking about different molecules. And the combination from photovoltaics to molecules is again a winning combination, or maybe wind and molecules. And these molecules can be transported on the classical way, via tubes, via trucks, to the point of the usage, and we will get some kind of energy hubs. Energy hubs will be connecting different storage options, long-term storage, short-term storage, with the different sources and loads. And energy hub will facilitate this exchange of the energy. So there is not really a decisive answer yet, but the molecules are going to be developed, which will play an important role in this long-term storage. And we are working on that in TU Delft. And this program is called eRefinery.
Miro?
Yeah, maybe I can add something. So as you have heard, we are on the terrain of the Green Village, which we consider a kind of experimental field, test field. And we are now busy with a project that combines photovoltaic technology together with electrolyzer to produce hydrogen, together with fuel cell, together with a battery, so that we are going to investigate whether such a system can deliver 24 hours per 7 days energy for this experimental residential area just from renewable energy source like sun. And we want to check whether hydrogen can be the medium, the carrier of the energy that makes this available for long-term storage as you are defining it. So we are doing these experiments, and when it's successful, then we can roll out, as was mentioned, not only to, let's say, experimental parts of the world, but into the real world. But again, it was also mentioned here, there are still a lot of legal issues, a lot of societal issues that we also have to tackle when we want to introduce these new technologies in real life.
As efficiency, which is unfortunately still low, below 60%. So if you have a round trip efficiency, you lose 50% of energy. But if energy is coming from the very cheap source, you can afford it to lose 50%. And we are also working on the increasing the efficiency and working on the solutions which will increase the efficiency and push it towards 60, 70, maybe even 80%. This is our dream. It's not yet, but we are working on it. And I'm sure within 10 years we have a solution.
There are situations where wind energy has negative prices already. There's too much out there, and you have to pay that people use it. The same will happen to solar. So we will have the situations more and more. And if this happens, if nobody wants your renewable electricity, please convert it into green molecules, store it somewhere, and sell it for a very, very good price in winter. So this is certainly happening.
Yeah, it's already now this situation.
Maybe to add to our discussion, so we are talking about energy transition and sustainable energy. Maybe it's good to say what we mean by sustainable energy, because often is said something about efficiency. So the sustainable energy has to come from renewable energy sources like solar and wind, but the conversion processes has to take place at the highest efficiency possible. That's why we are also focusing on the efficiency, because that combination of energy coming from renewable energy sources with the high efficiency of processes that we implement is for us the sustainable energy.
Thank you. Thank you, Guus, for your question. And the next one is Arthur Boulder. You have a question as well?
Yes, good evening, everybody. My question is about, we have an electricity grid which is almost all AC, alternate current. At the high end, we have high voltage DC power transmission, and at the low end, we have a solar cell with DC to the converter, and it goes to AC. Will the DC grid come into existence? So will we have a transition from AC to DC on a low and medium voltage level? And will this be studied in the new lab?
Yes, it's already happening. We already have a transition. We are developing some solutions for that. For example, you mentioned photovoltaics to DC. We developed a charger for electric vehicles directly from photovoltaics via DC to the car, so DC charging. And the grid is only for abundant energy, so directly from photovoltaics to the car. We are adding storage to that for the building. This is a 350 volt system, and it's creating a backbone for house system of 350 volts. This can grow to the microgrid on the residential level. It's coming really sneaky in your house, if you realize it or not. It's there. And later, I have in the house a 350 volt system from photovoltaics, and also I can connect the kitchen to that system to remove all the AC parts without knowing the consumer that the kitchen was supplied by the DC. And this way it will grow organically itself. Of course, the moment when the DC will be also interconnecting, but I would like to mention one important fact, and this is the potential for the DC, because through the same cable, we can get 50, 60% more energy just to use as a DC. So we have a concept of refurbishing the AC cables to DC on medium voltage level. It can be used for the areas which are overloaded already now. So you can put conversion steps on the both sides, and through the same cable in the ground, you can push more energy. In the areas which are overloaded, like example is the area of Central Station in Amsterdam, it is a solution, technical solution. No digging new cables, which takes years, cost fortune, but just adding and making DC. This is on the medium voltage. Then you have a lot of areas on the border with the different countries where this geographically, these two feeders are very close to each other, even touching each other, but they are in different phase. If you make it a DC connection there, you can exchange energy on the medium voltage level. And the same about the cities. The Hague and Delft are really next to each other, but they are different feeders. If you make it a DC link between, you can really support more renewable energy from The Hague to Delft or opposite way, whenever it is necessary. So DC links will really make a business model, business case, and will continue grow in the reality. So there are several business cases where it is really already making sense now. So DC, you will see it, you will get it at home, and it will grow on the different levels, on this low voltage level, medium voltage level, and high voltage level, and power electronics conversion with high efficiency, reaching 98, 99% is the key solution for this change. If Edison would have it 100 years ago, the grid of today would be DC. At that time, he didn't have it, so we call it missing a link of Edison. Power electronics converters are the transformers of today, and they are making it possible that these DC grids are plausible.
An important thing to add on this is that these are all solutions that attempt to mitigate what's happening at the verge between AC and DC utilization of electricity. But there are also situations in countries that dare to change energy to directly plan entire cities or entire neighborhoods directly in DC. So it's not that there is something that has to be adapted, but something that can be ground up built in DC
fashion.
fashion.
Compare it with many countries in Africa where they skipped the landline telephone discussions because they didn't have a landline. They just jumped immediately to the mobile phones. Now they are jumping immediately to DC. And developing countries is really the ground for the DC now, for the growth.
And I would also like to add that really extending DC grid is an option that we really have to look at, because when we look at the climate agreement that was adopted 2 years ago, and the goal there is to generate 70 to 80% electricity that we use today in the Netherlands from renewable energy sources, and it's mostly solar and wind, which deliver DC electricity. So you can imagine that the majority of the grid in 10 years will be based on DC. And to really save a lot of energy by converting from AC to DC and back, then the DC option of the larger electrical grid is there.
And to what was said about, well, earlier was said just now, tomorrow there's going to be a discussion also about cities in the sea, actually. So come back tomorrow for more on that. Thank you for that question. And we have Geert Kroon as somebody who's going to join in. Yes, for a question.
Hi, yes, I have a question. How does your work relate to big energy users? So for example, transportation industry, heavy industry, but also the urban environment is changing as well. We get more and more, for example, energy neutral buildings. So I was wondering, how does your work adapt to that changing environment as well?
Olindo?
Yes, in the built environment, there are many challenges on making sure that all possible surfaces are covered with PV. And this also implies that a lot of industrial roofs can also uptake the necessary necessary weight of the PV modules that have to be put on top of them to make them indeed more energy, net zero energy balanced. And there are a lot of innovations in that respect, making highly efficient PV modules to become more lightweight in order to have these buildings to be having less carbon footprint. At the same time, at the architectural level, there are also more and more innovations that try to combine different functionalities within PV modules. So we talk about the PV-powered multifunctional building elements that are elements that would make your building like normal bricks or tiles, but then that they are PV powered, and not only, they can also offer additional functionalities such as thermal regulation for your building, or giving merely aesthetic properties like color or texture. And all these innovations come together to make the overall energy balance of the building to be at least not negative, but equal to zero, or even energy positive. And we are talking about innovations like phase-changing materials that can be used as a heat sink for the heat generated by the PV modules. This type of innovation can, this heat can be used by heat exchangers in ventilation systems in buildings. Or lately, we have pushed the concept of photovoltaic chimney. That would be a double skin facade on top, to be put just in front of a normal wall. And this innovation can help not only generate electricity from the wall, but also creating a draft of air that will get warmer because of the PV production, and then intercepted at the roof of the building with, again, a heat exchanger to be used within the ventilation system of the building. So there are several innovations, and we come back to the concept of system integration. It's not all about the grid, it's also about putting our PV innovations into the built environment, in the urban fabric, with the many different type of innovations.
Thank you. Thank you, Geert Kroon, for your question. And the next one is Besitzer, who has a question for us. Curious to see you and to hear you. And until you, well, I have your question here, so I'm just going to ask it for you. Besitzer, I think your name is, asks, there's a lot of talk about the raw materials that are needed for the energy transition. What role will Delft play in the education and technology for this? And I want to ask this to Miro.
So the question is about education.
Mm-hmm.
We are a university. Our one pillar that we have to follow is educate our young generation. But in last years, what you experience, and due to energy transition, that also the way we teach has changed in such a way that maybe 10 years ago in our courses, we were just explaining how things work. And now we are really developing new courses to actually show students what will happen in the future. So through our education, we want to prepare, what I can say, new engineers, excellence engineers, and maybe also leaders in industry for the future. So not only explaining how, I don't know, photovoltaic solar cell works, but what it means for the future. Mm-hmm. So this is one important aspect that I noticed that we are changing in our education. Another one is that we really have to prepare not only students that join university for their job in the future, because energy transition will bring really a lot of jobs, but also other levels of the society to this change. So, for example, what we are doing is to creating online courses. Mm-hmm. So everybody who has access to internet can look and join these courses and get the education in this way. And I am sure that my colleagues can contribute to give more details about what we are doing in this respect.
Our courses are that popular that some courses are taken by 150,000 students, learners, even more. I can talk about the e-cars course, which is taken by 150,000 students all across the world. and they are all very happy with the content, and they are also participating in the other MOOC courses. This is a new development. We can really offer our knowledge to the whole world for very low price or for free. So this is something which is putting us on the edge of the technology.
And we export the Delft spirit to the world. Yeah? These people might not have the opportunities to come here to study here for many years, but over the internet it works. And we teach our students, yeah, if there is a problem, you can fix it with some technology. But why is the problem there? Think out of the box. Is there a reason? Maybe the reason is the problem. Huh? So we are giving them the attitude to think a bit bigger, because just fixing a problem and then the next problem is driving on site into the unknown future. No, we have to turn on the headlight and see what's out there and make smart decisions and really see the bigger picture. And that's a spirit that now with all these online things, we can really export everywhere.
And in addition that we just make courses that explain things, how they work and why they are important for future, we also try to develop their skills. So, for example, the practicals that we have at the university were also turned online. If Olindo can give some examples that you not only follow a course and learn how things work, but you can really do the experiments via internet in our laboratories.
An example?
Yes, we have actually two examples. One is the photovoltaic laboratory that is a course for master level students that is typically populated across the academic year by 60, 70 students. It has been translated into a virtual photovoltaic laboratory with a three-dimensional interface. It's essentially a web app that you can run on any browser. And it gives, in fact, the opportunity for students, learners that are not on campus to train and learn about also the equipment that are typically used to do measurements. So this is something that not indeed about only concepts, but also more on learning by doing.
Thank you. Ruud Lau, you have a question?
Yes, I have. Good evening, everybody.
Good evening.
Good evening. My question was, we want to make a sustainable world, but for that we need all these processes you talk about, but also these processes should be such that they don't pollute. So we have to investigate if we are doing the right thing with all these new technology. So if we have new technology, in the first place, we have to investigate that it does its job, but on the other hand, it should also be not polluting the environment. For example, it doesn't make a lot of noise, or it shouldn't use materials that are very, very rare on the world. So that was my question.
Absolutely. The keyword is holistic life cycle assessment, so that you don't see a product or a technology or an item isolated as it is, and it's maybe great, but it's sourced not sustainably, or it's a rare material, etc., or it's impossible to recycle or to dispose of. Yeah? So this life cycle assessment is extremely important, and that's again one of the puzzle pieces in the energy transition that is enabled with the digital transformation. So all the data, you can tag now everything, you can put the supply chain into a blockchain, you can make it transparent and auditable in the end, so that every product, every service, every idea that you implement gets a tag, CO2 tag, price tag, sustainability tag, fairness tag, etc. So this is another incredibly important dimension of almost everything we are doing, but especially for the energy transition. Yes, absolutely. I totally agree. It's a very good question.
Pavol?
And I would like to just add my experience. It was very difficult for me personally, because I'm a technology guy, to accept that we have to really also accept the other issues. It was difficult to accept it, but now I understand that this is an important point, and we are also developing courses where business, technology, but also environmental issues are connected to this.
When did that acceptance come about?
Because we understood that it's not possible without it.
Yeah.
But I have to say it was a very difficult process to digest in our minds and to accept it. But now I think we are on the same line. And this is also making us different maybe from the universities in the world, where they are still driving the same business as usual. We are already on the acceptance level from the point of view of the different aspects and soft issues, acceptance of the consumers on the different level. So we are multidisciplinary projects. We are including all these aspects, sustainability, material, circularity. We are including them in the projects now. And psychological part of the project is also very important. Acceptance of the consumers. We are automatically putting it on the roadmap. It's part of our thinking. And this change has happened in the last 5 years.
Olindo?
Yeah, there is also one important point when you look at the life cycle assessment of, let's say, renewable energy products, hardware that we would like to install. A very important part is the carbon footprint due to the transport from the places where these objects are industrialized and produced to the place where they're actually used and marketed. And this opens a lot of opportunities, not only to reduce the carbon footprint when things are produced in the place where they are going to be used. So I come back to the concept of circularity, but it also helps in eventually rising again the market and the job market towards these renewable energy solutions for places like the Netherlands or Europe. There is a very important trend right now on bringing back to Europe PV production, for example. Of course, I completely relate to the question because even when we talk about the PV modules with that are supposed to support energy transition and to be sustainable, there are still used materials that are critical, that are perhaps not immediately available. So in our group, we are trying to develop metallization types of metallization techniques that prevent us from using silver. And we are doing, for example, we are implementing copper plating technology. That is one way how to be less resilient on the use of this type of raw materials. One of them can be silver, for example.
Peter Hoek, you have a question. Good evening.
Good evening. Thank you very much. I was thinking about the courts stepping in Holland. And if you just assume that what they ask Shell to do, we would ask all the fossil fuel providers in the Netherlands to do and reduce 45% usage in the next 9 years for all the oil and gas. Do you see any bottlenecks to actually make up the amount of energy required using windmills and solar energy?
Olindo.
In the next 9 years.
Yes, thank you for the question. We are doing extensive modeling calculations to show that a massive penetration of photovoltaics in especially urban environment can support a vast majority of electricity needs, at least by population. We ran a couple of years ago a project for focusing on the city of Delft. And we found out that ideally mounting PV systems on every possible surface on the roofs of the city would give us 80% of the electricity needs of the city itself. Electricity needs, of course, not the whole energy needs, but it's already a very big chunk of it. So in this respect, we have to realize that the more we will install and more people will be used in even changing a little bit their way how to use our domestic goods, we will go in the right direction. I'm sure about that.
And certainly it is a combination of installing more of photovoltaic systems and wind turbines offshore on land. So maybe to mention some numbers, but our caller maybe know it, that recently, last 4 or 5 years, the delivery of electricity from renewable energy sources has exponentially risen. So I think at this moment, the renewable energy sources contribute almost with 20% to the generation of electricity. Maybe you remember that I mentioned 70 to 80% that has to be delivered by renewable energy sources in 2030, so in no time. But 5 years ago, it was only 4. So you see the enormous trend to really utilize the renewable energy sources also in the Netherlands. And you know that by scaling this up, the price goes down. So I am sure that the target that is in the climate agreement, 70 to 80% of electricity coming from renewable energies, that we will really get it.
Thank you for your question, Peter. And the next one is from Alex. And I know that he cannot join in via video. So I will ask the question that Alex has. And he asks, how are countries with an unstable electricity grid integrated in the energy transition? And what are the challenges for those countries? Peter.
That's a very good point. We should not orient our research, our interests on what we have here in our country. The world is bigger, and there's other make projects with all parts of the world, in Africa, India, you name it, and even go there and install their stuff that they have developed. So it's really exciting. And that gives us the perspective of what is really needed out there. And I can tell you the things that we are now developing has this global perspective, because distributed, affordable, idiot-proof renewable energy works everywhere. That's the beauty of renewables. It's not only clean and comes again the next day, every time you have the sun and the wind. No, the sun also shines on the roof of the poor man. Yeah, we don't depend on landlords that sit on an oil well, that blackmail half of the planet with that. In the future, it will be a common commodity for everybody, as it should be. Yeah? The sun shines down for all of us. We just have to pick it up, and we are developing the solutions for that.
Great.
What is interesting in this global that in Africa, many countries use still classical candles to give a light, and actually, it's cheaper to buy nowadays solar cells and to equip with the storage and give a light via solar energy than to buy classical candles. What needs to be developed is business concept. They need a loan. They need some financing possibilities to finance it. And this is going to be changing the lives of billion people to get a light, to get electricity from the solar energy, for example.
The impact is dramatic because not only environmentally, but also societally, because they have paraffin stoves for cooking. You replace them with electric. Yeah, the emissions are gone. You give them light so they can work longer in the evenings. They can make up a business. They can communicate with the next village. They have an electric vehicle. It's infrastructure that fuels development and a society as a whole. So it's the enabling spark. Yeah? Renewable energy is the enabling spark for development there. And it's free. We just have to pick it up.
Well, I like the energy that you give by with explaining that. So that's good. Let's go to the last question, and that is from, again, Guus van der Schouw. Let's see you, Guus. Hi, good to see you again. You have another question. That's good.
There we go. Okay, sorry, there was some pure music. Yes, I'm back again. Sorry, but there was a question called for another questions. Yeah, sorry, I'm from politics, so I'm always taking this a bit from a more negative side, I would say. You were talking a lot about, you were very positive about demand response and the possibilities of that also in us. But on the other hand, we have already been pushing the installation of smart meters for at least 20 years. And it's still not really getting to scale. What do you think are the causes of that, and how are we going to solve that?
smart meters are not enough. It's just the first step. Second step, didn't follow up. This is the problem. If you don't follow it up, well, the people are thinking, why should I have a smart meter? Why should I have a exposure of my behavior if I don't have any incentive, if I don't have any advantage out of that? I'm sorry to say it like that, but it's also political part.
And I wouldn't overrate demand response too much, honestly. There are different variants. They're price-driven, as we have mentioned already. If the price is not attractive, it will not happen. There are emergency-driven ones where the system is about to collapse, then you have to shut down things. This is happening quite often. So the larger industry companies are subscribed to programs where they can be shut off anytime, according to some rules, and by that save the stability of the grid. So there are different variants, but I would not bet on large-scale demand response with every washing machine and the refrigerator in the future. So I don't think so.
Therefore, energy too cheap, actually, too affordable, that these small margins wouldn't make a big difference.
Okay. I said that this was going to be the last question, but there's one more question that I thought, let me ask all of you this one. It was just too good to not to ask it. And this one is from Marije. Let's see if Marije can come in herself. I heard that and read that perhaps it is not possible with camera. And if not, then I'll, there you are.
1 second.
Oh, okay. 1 second is gone already, Marije.
Can you hear me or not?
Yes,
not?
Yes.
Okay, I'm at work right now, so that's why I was still muted, because I can be called any minute. So my question is how do we motivate these technology changes? Because we can make amazing and great technology, but it's very hard to execute it. So I think we need to be aware of it, of course, but why would we do it?
You know.
Sorry, what was exactly why we are doing this energy transition?
So what are the different ways that we can motivate the transition to durable energy technologies?
So I think, and it was mentioned here, economical aspects is probably the biggest driving force that people change behavior.
The only answer.
I think this is already the answer. And I noticed it by myself. Actually, I put my first PV system on the roof of my house here in Delft in 2002. So already almost 20 years ago. And I can tell you that it changed my behavior because I have realized how much it takes to generate 1 kilowatt hour with this PV system. And then I also realized how easy you can use 1 kilowatt hour when you just forget to put out your lights, or that you are using equipment that you don't need to use. And then you start realizing these things. And there was also another participant of this discussion that mentioned that behavior of people. And I believe that actually implementing renewable energies can change the behavior of people. And maybe we should really take it other way around, not trying to change the behavior of people to accept energy transition, but to make energy transition to change the behavior of people. And I notice it on myself and also via my colleagues who did the same thing. They change their behavior, how they use electricity at least, but I think energy in general now when they live. So economic is one of the probably the most important driving force.
I can just strengthen this, adding solar cells on your roof and then following on the mobile phone how energy is produced, how much energy produced per day, what is the shape of the energy.
Yeah, we compare it every day. Who has more?
Well, okay.
We're just doing it before this discussion.
Just to follow it and then it's changing your behavior automatically because you start to realize, I'm asking my wife, just put the washing machine around the noon because then it's energy which is for free from the solar cells.
Yeah, I can second that. Also, my kids know it, and it really changes it gets more visible, and it's yours. It's your energy. That's the difference, I think. And even if I rent these square meters on a solar farm somewhere, not on my roof because I don't have a roof, maybe, but that's also possible. It's mine. I can use it. And with the digital transformation and the energy transformation, I can store it, I can sell it in the future. That changes a lot. So the identification and the visibility of energy gets different. And now it's positive and green. In the past, it was dirty and expensive. That's a totally different style. And another example, because Miro said the cost is the only thing that matters. If you look at the offshore wind farms that are now tendered and built, they're built without subsidies. Yeah? Coal is subsidized. Nuclear power is subsidized. Everything is subsidized, but wind not. Yeah, it's built. And if the pension fund managers on the Wall Street invest into these wind farms, then there are no more questions asked. Yeah? Then you can consider it solved. Yeah? The money flows, period.
So I believe educating people is the key to the solution and key to the success. And educating the people means to give them also the information about the energy produced, about energy balance, and this way they change the behavior itself. I believe in the good people.
Olindo?
Yeah, let's not forget that the economics of renewable energies, and especially when we look at private citizens, the economics of PV systems is still a field in development. But one thing is sure, that having a PV system on your roof can increase the value of your real estate. So this is also coming back to the economic matter that provided that we want to do something that goes in the direction of having a cleaner world. When it kicks in also the economic reasoning, if you have a house, you may want to invest also in a PV system because it can also increase the value of your house.
So to conclude, at the end, it's all about money.
It's all about the money. It's all about the money. There should be a song about that, huh?
Do you agree?
So money, education, and a good role model.
Yeah, I think you are right. Yeah.
But a tip for all of us.
A little bit, maybe also the social credit that you get when you can tell others that you're doing good to the world. It's a tiny one, but people do it for that as well, of course.
Absolutely.
Thank you for
1 second. I try to explain it in a picture. I will share it with you.
Okay. Wow, that
Please
is
send us that.
amazing. Yeah, find them on the university page, and then I think they will be happy to receive it. Thank you for this amazing last question, Marije, and for, of course, the great answers. Thank you for joining our event and all of your lovely questions. Thank you, guests, for your interesting insights, and for more information on this topic, check the TU Delft for Life portal and our follow-up email that we will send you. Of course, we will send you our virtual tour in the ESP Lab, where you can find additional information and stories from our guests tonight. Tomorrow, we will host the last event of this week, and it is on adaptation to sea level rise with 3 wonderful keynotes. You can still join us then. For then and for now, have a lovely evening.